Hello, and welcome to the J-Axis on YouTube. I am your gracious and humble host, Jason Lewis. Decided to get this page kind of started again after not having used it for quite some time. I started a YouTube page about the same time that I started the Instagram page of the J-Axis, and I wasn't really getting much of a response on the YouTube at the time, so I kind of just focused on Instagram. But I've reached the point now where I feel like people are actually going to be willing and wanting to watch these videos and entertain me and my theories and hopefully be entertained themselves. So the first episode of this web series that I'm starting, I wanted to talk about the J-axis and what it is and sort of where I came up with that term and how it plays into 4D geometry and how we might be able to use this geometry to possibly create a wormhole in the future. So it all starts with thinking about the first 3D axes that we know about, which we'll picture them in a cubic setting. And of course you have the vertical y-axis, your horizontal x-axis, and your lateral z-axis. Now I say that the fourth dimensional j-axes, because there can be more than one, exists in all the diagonal corners as they would appear in a cube, from corner to corner, which means you have four different possibilities of them existing. And when you look at that in a cubic setting, the line goes from a diagonal corner to another diagonal corner, but these corners are 90-degree convergences. So I think that using that to go from corner to corner is sort of on the way and expounding upon the Pythagorean theorem of, instead of using 2D right triangles, it's using 3D 90-degree corners of cubes, or what can appear that way. Because when you're looking at a cube, it could also be, if you're at the right perspective, two overlapping equilateral pyramids that appear to be like a cube from that angle. And kind of share some slides to show how some of the math plays into that and the convergence points of the axes and everything. And when you look at it like that, the j-axis, which is the fourth dimensional axis that goes from corner to corner in a cube, if you're looking at it in the setting where it's two overlapping equilateral pyramids, it's actually an apex to apex measurement. So it's expounding upon the Pythagorean theorem in the 2D way by being the 3D corner setting as one perspective, but also using the anomaly that appears within geometry as far as equilateral triangles, being that any triangle that you take and you divide its angles by 3, and then take your 3, after you divide them by 3, take your 3 quotients and add them, you will always receive the sum of 60. And that aligns with the 60 degrees of an equilateral triangle. So no matter which perspective you're seeing the shape in when you're imagining the j-axis, whether it be cubic or two overlapping equilateral pyramids, there's still a principle of geometry that sort of can explain how that diagonal corner to corner or apex to apex measurement can exist. Now, looking at some of these diagrams, you can see how the j-axes create what looks like would be a vortex if you were to rotate it upon what I'm calling that fifth dimensional axis that doesn't exist in the cubic setting in any sort of geometrical or mathematical manner, but it exists when you look at it as the separate equilateral pyramid perspective. So that fifth dimensional axis, if you look at it the way it aligns with the 4D j-axes, it would create a sort of vortex if you were to spin the two shapes as if they were one along that fifth dimensional axis. And as it creates that vortex, it's taking two separate shapes and causing them to be the illusion that they're actually one cube setting. And that's sort of the same thing that we're thinking of when we're thinking of how we would want to connect 2 points in space and time through a wormhole, by connecting two separate spaces in time and overlapping them into one. So it's the same principle, just imagine in sort of a geometrical manner of how you would do that. And that is sort of why I call that fifth dimensional axis the Einstein-Rosen bridge, because that's what Einstein theorized what a wormhole was. And you really can't get that unless you imagine the j-axes being able to exist in both possible manners. And that's sort of why I call that the Pythagorean addendum, because it's just a 3D, 4D way of playing upon what we already see in different principles of geometry. And when I first came up with that, I wanted to give it some sort of a name, but I couldn't really put my own name or brand on it because it was just expounding upon the already set Pythagorean theorem. That's why I called it the Pythagorean addendum. And that's where the J-axis sort of got its name. Is I was just like, well, I found this cool pattern, I want to put my stamp on it kind of somehow. So my name's Jason, called it the J-axis. That's the boring story behind the name on that. As far as creating the wormhole with the two separate equilateral pyramids that you're rotating to kind of represent one whole cube, it's sort of the same thing, same type of illusion that if you've ever watched the movie Sleepy Hollow or played the video game Bioshock Infinite, that they show where they've got the bird on one side of a slide and the cage on the other, and then you spin it, and as you spin it, all you can perceive is a bird inside of a cage. Now, all perspectives are possible of being the separate bird, the separate cage, or the overlap bird within the cage. So it's all playing upon illusions, and that's sort of what I think a wormhole is it's an illusion of a black hole, one that's safe as in it bends time and space, but it's not destructive as a black hole would be. And I guess that sort of explains everything that I want to talk about in the first episode. Like I said, I'm just getting started, just getting everything up and going again with this channel. So it's going to be just like the J-axis page on Instagram was. It's going to sort of evolve as it goes, as I get better tools and as I learn how to use them better. It'll get better and better, and trying to bring the best quality content that I can. I appreciate anyone and everyone who tuned in to watch this. If there's any questions or concerns or anything, always be free to reach out. And if you haven't checked me out on Instagram yet, the J-axis under the same name, go check it out. And anybody has any suggestions on what they'd like me to discuss in the next video or any future videos, please reach out. I'm always willing to listen and hear your perspectives. All right, have a good day. Thank you.